Hello students. In our last last chapter we studied about alternate current. Today we will study the electromagnetic waves. In this chapter first we will try to understand what is Ampere law and the displacement current. Here Ampere's law already you have studied in your magnetism chapter. It says that the line integral of magnetic field over a closed loop carrying current is given by nu 0 IC, where IC is the conduction current. Now, if we apply the same Ampere Circuital Law for the case of capacitor, let us see what will happen. Here an alternate current is supplied. This alternate current gives rise an alternating current through the wire, and at loop 1 using Ampere Circuital Law we will get magnetic field given by B dl equal to nu 0 IC. And in the case of loop 3 also the Ampere Circuital Law is valid. Now, let us see what will happen about the magnetic field between the plates P1 as well as P2. Between P1 and P2 we have electric field E equal to sigma by epsilon 0, or the electric flux pi is given by Q by epsilon 0. Now, here in this case there is no current. So, the Ampere circuit using Ampere Circuital Law B dot dl does not give any meaning. Now, let us check the validity of Ampere Circuital Law here. Here in this case phi is given as Q by epsilon 0, Q is equal to pi epsilon 0. We get dq by dt is equal to d phi by dt multiplied by epsilon 0, and dq by dt is nothing but it is I is equal to epsilon 0 d phi by dt, where pi is called electric flux, it is subscript as E. So, the rate of change of electric flux gives rise a current which we call here as displacement current. Now, the continuity of Ampere Circuital Law is valid only if we take the displacement current. So, the new Ampere Circuital Law is given by B dot dl is equal to nu 0 IC plus ID, where ID is called displacement current, and this displacement current arises due to the rate of change of electric flux. Now, we will see the displacement current. We know that Q is equal to epsilon 0 pi, or dq by dt is given by epsilon 0 d pi by dt. So, the rate of change of flux gives rise a current which is called a displacement current. This current makes the continuity of Ampere Circuital Law. Next, we will see the Maxwell Equations which gives the theoretical concept of electromagnetic waves. Now, we will see the Maxwell Equation which gives the concept of electromagnetic waves. We have two equations here. First one is time independent, second one is time dependent. In time independent Maxwell equations, we have first one the Gauss law, which is given by E dot ds is equal to Q by epsilon 0. This equation shows that a charge which is at rest or a charge which is moving produces an electric field. This is time independent equation in a space. Next equation, which is also said to be as time independent equation, is given by B dot ds is equal to 0. This equation shows that monopole cannot exist. When we take a magnet, it always exists dipolar form. So, these two equations are said to be as equations which is time independent, and this does not depend upon the time. Next, we will see the time dependent equation. Here we have Ampere Circuital Law B dot dl integral is equal to nu 0 IC plus epsilon 0 d phi by dt bracket close, or if IC equal to 0, this law can be written as B dot dl is equal to nu 0 epsilon 0 d phi by dt, where flux is electric flux. This equation represents that the rate of change of electric flux produces a magnetic field. That is, when there is a time rate of change of electric field that gives rise a magnetic field. We have the line integral of magnetic field which is given by nu 0 epsilon 0 d phi by dt. Let this as equation 3. Now from the Faraday equation we have induced EMF is given by E is equal to d phi by dt, where phi b is the magnetic flux. So we also know that E is equal to dE divided by dl, that is electric field is nothing but the potential gradient. dE is equal to E dl, or E is equal to integral E dl. Now let this as equation 4. Now equation 4 can be written as E dot dl is equal to d phi by dt. Let this as equation 5. Now from 3 and 5 we find that time rate of change of electric flux produces magnetic field. Similarly, time rate of change of magnetic flux produces electric field. These two equations are time dependent equations, and these two equations are responsible for electromagnetic waves. Now the electromagnetic waves are the outcome of interaction of these two equations, that is the oscillating electric field produces a magnetic field and an oscillating magnetic field produces electric field. Interaction of these two fields produces a wave which is said to be as electromagnetic wave, and this wave travels perpendicular to the magnetic field vector as well as electric field vector. Therefore, an electromagnetic waves is produced due to the oscillating charge particle or an accelerating charge particle, and that can be defined as the field, the waves produced due to the interaction of oscillating electric as well as oscillating magnetic field. So the electromagnetic waves graphically can be represented as follows. Now we will see how electromagnetic waves are actually produced. When we take a charge particle and if we accelerate the charge particle, it starts to oscillate. This oscillating charge particle produces an oscillating electric field, and this oscillating electric field in turn produces an oscillating magnetic field. Interaction of this oscillating magnetic as well as electric field produces a wave that moves perpendicular to both magnetic field as well as electric field in a free space with the speed of light, is said to be as electromagnetic waves. So electromagnetic waves propagates perpendicular to the magnetic field as well as electric field. Here the two equations which are responsible for electromagnetic waves is given by Bz is equal to B0 cos omega t minus kx and Ey is equal to E0 cos omega t minus kx, where omega is said to be as angular frequency. It is given by omega is equal to 2 pi by t, where t is time period, and k is called propagation constant. It is given by k is equal to 2 pi by lambda, where lambda is the wavelength. Here in the graph you can see that along y axis, so magnetic field along y axis, electric field is represented, and this electric field is given by Ey is equal to E0 cos omega t minus kx. Similarly, magnetic field which is acting along z axis is given by B z is equal to B0 cos omega t minus kx. So this is the theoretical production of electromagnetic wave by the help of Maxwell equations. Later on, Hertz practically predicted the presence of electromagnetic waves that is obtained due to the interaction of oscillating electric as well as magnetic field. Now we will see some of the properties related to electromagnetic waves. Here first one is the electromagnetic waves are transfer in nature, that is the electromagnetic wave propagates perpendicular to the direction of electric field as well as magnetic field. Now let us prove this concept. Here we will take a figure which represents the propagation of electromagnetic waves as shown in the figure. Let us suppose that in x direction electromagnetic waves are propagating, and let us suppose that the equation of electromagnetic wave is given by the equation of electric field as well as magnetic field, we will determine later on. Now imagine that electric field is acting towards x axis. If it is acting towards x axis, now using Gauss law we can find out the electric flux. Now let us take a small cube here which encloses some volume, let us say A, B, C, D, E, F, G, H. Now, let us suppose that electric field is acting along x axis. Here on both the surfaces A, H, E, D, area is acting towards opposite direction to each other, that is, one is acting towards negative x axis, another one is acting towards positive x axis. So, this can be written as like this, dy dz, here also dy dz. Now, we have two surface areas dy dz on both the places, and suppose that electric field is acting along positive x axis. So, here you can take this field as E2, and the field which is acting at surface AHED, suppose it as E1. Now, according to Gauss law, for this complete cube, E dot ds must be equal to 0, as there will not have any charge enclosed by this cube. Therefore, E dot ds, integral E dot ds is equal to 0. For all the places, we can have E1 dy dz for first surface, and for second surface you have E2 dy dz. Similarly, for the remaining two faces, that is forward as well as backward, upward and downward, we will get the resultant is equal to 0. So, the sum of these two will be equal to 0. Here for the first phase, we are seeing that both electric field as well as a projection vector for the area is acting in opposite direction to each other. Therefore, this can be written as minus E1 dy dz integral, and for this one you can write as the same as it is, E2 dy dz is equal to 0. Further, this can be written as E1 dy dz with negative sign here plus E2 dy dz is equal to 0. Or dy dz can be taken as common. After taking dy dz as common, you will get E2 minus E1 bracket dy dz is equal to 0. The equation 1 implies that either dy dz is equal to 0 or E2 minus E1 is equal to 0. We know that area cannot be equal to 0, therefore, dy dz cannot be equal to 0. The ultimate factor which is left out here is E2 minus E1 is equal to 0. So, this implies that E2 is equal to E1. So, we find that the considered electric field at surface first one and at surface second one is comes out to be equal, and we know that a constant electric field cannot produce an electromagnetic waves. That is why the electric field do not act along the direction of propagation of waves. Hence, electric field must be perpendicular to the propagation of electric field. Similarly, we can prove that magnetic field is also perpendicular to the propagation of wave, and from Gauss law we know that B dot ds is equal to 0. For the surface 1 and 2, we have magnetic field as B1 minus B2 ds is equal to 0. ds is equal to 0 or B1 minus B2 is equal to 0. ds cannot be equal to 0 because it is area. The ultimate factor which is left out here is B1 minus B2 is equal to 0. This implies that B1 is equal to B2, and we know that a constant magnetic field will also not produce electromagnetic waves. Therefore, B1 and B2 must be perpendicular to the propagation of electromagnetic waves. We saw that in first property that electromagnetic waves are transverse in nature, that is, electric field as well as magnetic field vector are perpendicular to the propagation of electromagnetic waves. Next property of electromagnetic waves is that the electromagnetic waves travel with the speed of light in a free space. Let us see this. Now, electromagnetic waves is partially contains electrical energy and partially magnetic energy. Therefore, the electrical energy density is given by UE is equal to half epsilon 0 E square, and the magnetic energy density is given by UB is equal to half B square by nu 0, equation 2. When time t equal to 0, the total energy will be electrical at time t after some time UB is equal to half B square by nu 0. According to the conservation of energy, both these energies must be equal. Therefore, half epsilon 0 E square is equal to half B square by nu 0. Half of get cancelled out, you will get finally epsilon 0 nu 0 is equal to B square by E square, or E square by B square is equal to 1 by epsilon 0 nu 0. Let this as equation 3. Now, from the concept of magnetism, we know that C is given by E 0 divided by B 0. Let this is equation 4. Now, substituting the value of E by B in equation 3 gives C whole square is equal to 1 by epsilon 0 nu 0, or C is equal to 1 divided by under root epsilon 0 nu 0. That is, the electromagnetic waves in a free space will have the velocity which is equal to the speed of light, and it depends upon the electrical permittivity and magnetic permeability, and the relation between the speed of light and the properties of electrical behavior and magnetic behavior is given by C is equal to 1 by under root epsilon 0 mu 0. If the medium is not free space, then the velocity of light may be represented by V, and it will depend upon the dielectric property as well as magnetic permeable property of the medium. So, V is given by 1 by epsilon nu, where epsilon is the permittivity of the space and mu is the permeability of the space. So, we know that epsilon is nothing but epsilon 0 epsilon r, and mu is nothing but it is mu 0 mu r. Further, this can be written as V is equal to 1 divided by epsilon 0 mu 0 under root multiplied by under root epsilon r mu r, under root epsilon r mu r. So, we know that the value of C is nothing but it is given by 1 by under root epsilon 0 mu 0. So, V comes out to be 1 divided by epsilon 1 divided by. So, we have the value of C is equal to 1 divided by under root epsilon 0 mu 0, and the value of V if the medium is not free space is given by V is equal to 1 divided by under root epsilon 0 mu 0 multiplied by the other factor. In place of 1 by epsilon 0 mu 0, we can put the value as C, which gives V is equal to C divided by epsilon r mu r, or under root, or this can be written as C divided by V is equal to under root epsilon r mu r. So, C by V is called the refractive index of space, and this refractive index depends upon the permittivity as well as permeability of the medium. So, mu is equal to mu refractive index is equal to under root epsilon r mu r. The next property of electromagnetic waves are they do not require any material medium, that is it is not a mechanical wave, that is why it does not require any mechanical medium. Without mechanical medium they can propagate in a space. Third one, the total energy of electromagnetic wave is given by total energy density. Total energy density of electromagnetic wave is given by half epsilon 0 E square plus half B square by mu 0, where E is E0 sin omega t minus kx and B equal to B0 sin omega t minus kx. E here you can write Ey, and for B you can write Bz. Fourth property of electromagnetic waves are they show the property of reflection, refraction, polarization, diffraction as well as interference. Here I have written some of the properties of electromagnetic waves on the blackboard, on the board. which includes the travel with the speed of light in a free space, and the total energy of electromagnetic waves is half of electric energy and half of magnetic energy. Next one, they show the property of reflection, refraction as well as polarization, interference, which we will study in next chapter. They obey the principle of superposition, that is, regarding the topic of superposition you already learned in 11th class. It says that the total displacement of wave which are interfering will be equal to sum of the displacements of the individual waves which are interfering at a particular point. They do not need mechanical medium. So, just like other mechanical waves, they do not need mechanical medium, and they show the transverse property. They are not affected by electric or magnetic field. So, the property 7 says that they are not affected by electric as well as magnetic fields. That is, the electromagnetic waves which are produced is actually packet of energy known to be as photon or quantum. This quantum of energy is independent, that is, it is chargeless and have a rest mass. Therefore, it is unaffected by electric as well as magnetic field. Next property shows that the electric field vector is greater than magnetic field. That is, in our previous chapter, in the chapter of magnetism, we studied that C is equal to E by B. C is the speed of light. It is directly related to electric field. Therefore, the optical behavior of electromagnetic waves is represented mostly by electric field rather than magnetic field. And in the beginning I told you that they are produced due to accelerating charge particle. The accelerating charge particle in turn produces an oscillating electric field. This oscillating electric field produces a magnetic field, and interaction of both the fields gives rise electromagnetic waves. In our previous topics we saw that Maxwell theoretically explained the existence of electromagnetic waves. The proof for existence of electromagnetic waves is given by Hertz experiment. The experimental setup consists of an inductor. An inductor is connected to high voltage. This high voltage which is applied to inductor is in alternating form. As a result of that, it produces a high electric field. This electric field acts between the two capacitor plates, and finally the wave which is produced here is detected by a detector. Let us try to understand in greater extent. The inductor produces an electric field in a free space between the plates. This electric field ionizes the gas molecules present between the capacitor plates. As a result of that, it provides a discharge path to the charge present between the capacitor plates. This charge starts to oscillate between the points A and B. So, an oscillating charge particle produces between A and B due to the ionization of air molecules, that is because of high magnetic field, magnetic energy produced by the inductor across A and B. Due to that accelerating charge particle, an electromagnetic waves is produced, and Maxwell unable to give the practical proof of experimental proof of this electromagnetic waves. So, Hertz tried to give the experimental proof of this. The electromagnetic waves which is produced at point A and B due to the oscillating charge particle moves towards the detector. A detector consists of S1 and S2. Basically, it is an aerial. This electromagnetic waves set up a current between S1 and S2. As a result of that, a spark is seen between S1 and S2. This implies that electromagnetic waves can have the tendency to move in a free space. Hertz also seen that when this detector is placed in horizontal plane, there is no current induced between the points S1 and S2. Current is only induced when it is placed in vertical plane, that is when it is placed in a vertical plane, the transverse nature of electromagnetic waves strikes at point S1 and S2 and gives rise a current which is detected by the detector. This shows that electromagnetic waves not only produces due to the oscillating charge particle, it also shows the transverse nature of electromagnetic waves. That is, the electromagnetic waves which are produced due to accelerating charge particle are transverse in nature, which are perpendicular to both electric as well as magnetic field. Here we have some more properties. The first property here is they have momentum which is given by P is equal to energy divided by C, and they have the radiation pressure which is work divided by volume, and it is the energy density which is equal to half epsilon 0 E square and or half B square by nu 0, which we already studied. They exerts a force when strikes at a surface. That is, when electromagnetic waves strikes at a surface, it gives a force to the surface. It has an intensity which is represented by the propagation of energy per unit area per unit time. That means when electromagnetic waves propagates in a space, they carry some energy per unit area per unit time. That is, when it strikes at a surface, it produces an intensity which is read by energy per unit area per unit time. Here we have energy density U divided by V is equal to epsilon 0 E square, or this volume can be written as A multiplied by L, area multiplied by L, or U divided by A is equal to L multiplied by epsilon 0 E square, U divided by A, T has been multiplied on both sides, U divided by A multiplied by T. This factor, that is energy per unit area per unit time, is said to be as intensity, which is equal to epsilon 0 E square L divided by T, and L by T we know that it is a speed. This can be written as C, or here we have half factor, or I is equal to half epsilon 0 E square C square divided by C. With C has been multiplied in the numerator as well as denominator, the expression becomes I is equal to half epsilon 0 E square C square divided by C, and the value of C square is nothing but it is 1 by epsilon 0 mu 0. Epsilon 0 get cancelled out, and finally you have an equation which is equal to half E square divided by C epsilon 0, half is half multiplied by E square, the value of C is equal to E divided by B, and it has been substituted in the equation. Finally we got I is equal to half E multiplied by B mu 0. These are the some of the properties we dealt on today, and the remaining topics we will see in our next class. Till then I hope that you all will practice. Thank you.